9.4 Parametric Equations. In this lesson, we're going to talk about what parametric equations are and how to use them. When you have a rectangular equation, it gives you the graph. That's all it does. You go y equals negative x squared over 72 plus x. It gives you a graph that looks like this. When you do a parametric equation, we add a third variable called time with a t. That lets us know how our graph moved over time. So you can see that arrow here. That lets us know that at the start it started here, and then it started going in this direction. This is the exact same graph, one under rectangular and one over parametric. And the parametric gives you a little more information, lets you know the motion it went with. So in this lesson, we're going to talk about how to break a graph down into parametric equations and vice versa. So for a particular motion problem, x and y are continuous functions of t, and the resultant path is called a plane curve, which is a continuous function. So basically, the x is its own function, the y is its own function. So we're going to see like this: x is equal to f of t and y is equal to g of t. And we call those parametric equations, and t is known as the parameter. Okay, let's start off by doing a graph of a parametric equation. So we're going to graph this, we're going to describe the orientation. We're going to do a big old chart. We have t here, we have x and y. So we'll start with -2, -1, 0, 1, 2, and 3. We're going to plug -2 into here. -2 squared minus 4 is going to be 4 minus 4, which is 0. And then plug -2 into here. -2 over 2 is -1. So we have a point, 0 and -1. That's our first point right there. And then we're going to keep on doing this. Plug in -1. -1 squared is 1. 1 minus 4 is -3. -1 to here is -1/2. So we get -3 and -1/2. So that's going to be right here-ish. And then we're plugging 0. 0 squared minus 4 is -4. 0 over 2 is 0. So you get -4 and 0. So right now our curve is going like this. And that's the direction it's going. Plug in 1. 1 squared minus 4 is -3. 1 over 2 is 1/2. -3 and 1. 2 squared minus 4 is 0. 2 over 2 is 1. So we have 0, 1. Right there, our graph's going like this. So again, let us know that it's going in this direction. We started here, we're going this way. And then finally 3. 3 squared minus 1, 9 minus 4 is 5. 3 over 2. So we have 5 and 3 over 2. And little arrows, so every once in a while to let us know that's the path or direction. So that's our curve. And then we describe the orientation by doing the little arrows. Okay, the next one. We're going to do one of these. Use a graph utility to graph the curves represented by parametric equations using a graph in the vertical line test, which curve is y as a function of x. So on our calculator, we actually could put it in parametric form. If you go to mode, you see right here it says functions, parametric, polar, and sequence. So we're going to go over here and put it parametric. Now when I do that, when I go to y equals, it's a totally different graph. X1, y has our x equation and our y equation. For our first one here, our x equation is t squared. And now when you put the variable button, it gets us a t. So we're in rectangular form, it's an x. We're in parametric form, it's a t. We're in polar form, it's going to be a theta. I'm going to put t squared. And then down here, I'm going to put t cubed. We have that. Before I graph, I'm going to hit window. I want to make sure I go from -4 to 4. We'll do the same for min. We don't want to go too far. If I hit graph on this, we get a graph looks like that. Now that is not a function. It does not pass a vertical line test. That's how that one looks. The first one, A, would look like this and like this. Now, since we're here, let's do B. On B, I get this t, there's that, and t squared. That's all set. That one would be a function. It looks like an x cubed graph. Let's do t squared, and then just t, I think. Hit graph on that, and we get another non-function. That looks like a sideways parabola. Only b is a function. That's how we graph on our calculators using parametric. How about if we want to eliminate the parameters? What that means is, I have a parametric equation. I just want a basic, regular, rectangular equation. What you got to do is solve for one of the equations. If possible, make it the linear one. So you have two choices here. You don't want to solve for the t squared one. Make it the linear one. So you solve for t in that one. And then you just, once you have that, you just plug it into the other one. And there you go. In example 3, we're going to eliminate the parameter. Now this has 2 t's and this has 1 t. When we limit the parameter, we just want to get rid of all the t's. We're going to solve for a t in one of them and then plug it into the other one. In this case, I'll suggest here because there's only 1 t. We're going to go down there. We're going to try to get that t by itself. The first thing I would do would be get rid of the square root. Let's square both sides. So we get x squared equals 1 squared, which is 1. And then this, the square goes to both of them. And that just becomes t plus 1. Now I would probably multiply both sides by t plus 1. Because it's in the denominator, we want to get rid of it. So we're going to get t plus 1 times x squared equals 1. And we're trying to get t by itself. Let's just divide by x squared. We get t plus 1 is equal to 1 over x squared. Then subtract 1 from both sides. We get t equals 1 over x squared minus 1. So that's our t. What we have to do is substitute that into the other equation for t. Actually, there's 2 t's for both of them. Let's write that over here. Y equals t is 1 over x squared minus 1 over t, which is 1 over x squared minus 1 plus 1. Now this right here reduces. We get y equals 1 over x squared minus 1 all over 1 over x squared. That looks a little messy. So let's clean this up a bit. Alright, so divide signs. 1 over x squared minus 1 divided by 1 over x squared. When you divide by a fraction, you just multiply by reciprocal. So really, we have this times the reciprocal of that, which is x squared. And then we distribute. X squared will cancel out. We get y equals 1 minus x squared. So that's the same graph with the parameter eliminated. This, graphing this, is the same thing as graphing that in rectangular, just without the motion. That's how you eliminate a parameter. On one of the equations, you solve for t. Make sure it's not the t squared, because then you get plus and minus, it gets messy. So just get the linear one, solve for t. Then once you have that, plug it into the other one and simplify. The next, find a parametric equation for a graph. And this one, what if I have a normal graph? I want to make it a parametric equation. That's what we're doing here. Find a set of parametric equations to represent the graph of y equals 1 minus x squared using parameters t equals x and t equals 1 minus x. We're going to do 2 of these, basically. And when you set up a parameter for t, you can do anything you want. So in this case, we're saying, hey, t equals x. Now remember, when you come up with the parametric equation, you should have 2 formulas. You have x equals and you have y equals. We already have our x equals 1. X equals t. That one's done. They gave it to us. Now we want to figure out what the y equation is. All we're going to do is substitute this guy in for our equation. We're trying to break up this equation here. So now that we know x equals t, just plug in t for x, and we're going to get this. Y equals 1 minus t squared. And that's pretty much it. And you separated it. Y equals 1 minus t squared. Like that. So that's this equation broken into a parametric equation. You say x equals t, but now you know x is t, you plug it into here, and then you get 1 minus t squared. That's an easy one. That's too easy. Let's do b. In b, we're going to say t equals 1 minus x. So again, you can make whatever you want as a parametric as the parameter. Once you set your parameter, then from there you have the base when you solve x and y. We have to figure out what x and y is here. X is easy. Just go get your parameter and solve for it. We're going to add x. Both sides, you get x plus t equals 1. And subtract t. X equals 1 minus t. That's what x equals. And all we're going to do is go back into this equation here. And wherever you see an x, you're going to plug in what x equals. So we have y equals 1 minus x squared. But now we know x is 1 minus t. And let's simplify it. 1 minus t squared is 1 minus t times 1 minus t. We have 1 minus parentheses, or brackets, 1 minus 2t plus t squared, like that. Distribute the negative. So you get 1 minus 1 plus 2t minus t squared. These cancel out, and we just get 2t minus t squared. That's that parametric. That's this equation broken up by this parameter. T equals 1 minus x. That's how you break it up. You choose your parameter, or they give you one to choose, and all you have to do is find the x and y value for it. Given the parameter, use that to find your x. That's easy. Just rearrange it, get your x by itself, and once you get your x, plug that into the y, the original equation, to find your y. And that's the lesson.